Hello, everyone. Welcome to Grounded, the Regenerative Farming Podcast, live. So it's great to have quite a few people here this evening, spending time with us, sharing the evening here on a Wednesday night. Tonight's episode, or rather, I guess further installment of the Grounded Podcast is Healthier Soils, Healthier Animals, a focus on the animal health impact of good soil management. And so my name is Kyle Richardville, and Stu Johnson, my co-host, is actually stuck on a plane in Amsterdam. They can't figure out how to get the stairs on the plane, I suppose. So he'll be joining us shortly whenever he gets back in the terminal. So for now, you're all stuck with me. If you want to throw your questions in the Q&A chat, I'll try and keep my eye on it. Again, we're a host down, so try to keep an eye on the conversation. So we might not get to the questions until the end, but maybe when Stu joins, we can start to sprinkle in the questions. So joining me tonight are Shaun Maw, farmer up in Northumberland, I believe. I have that county correct. And Lee-Anne Oliver of Ruminant Revivals and the Fold Vets Group. Is that right?
That's right.
Very good. Very good. So Shaun, if you want to start us off and introduce yourself and the farm, that would be much appreciated.
My name's Shaun Maw, beef and sheep farmer in Northumberland, just above Hexham. Did a bit of arable as well, but just this year I've kind of stopped that for now, just till it gets a bit more profitable. That's about it, really. I've been mob grazing and that since about 2019 was when I started. And just kind of changed it a bit, but carried on till now. That's about it.
Thank you very much, Shaun. Lee-Anne?
So I'm Lee-Anne Oliver. I'm a veterinary surgeon. I just do farm animal work. So my kind of day-to-day job, I suppose, which takes about maybe 80% of my time, I'm a primary veterinary surgeon in first opinion practice, beef and sheep vet, working out of Hexham. So I have done Shaun's vet work now for as long as he's been at Beaumont House, which is where he farms just now. But I also have founded a consultancy company called Ruminant Revival, which focuses on reducing chemical and pharmaceutical inputs from farming systems. So obviously there's a huge kind of alignment with the principles of regenerative agriculture in that. And I've seen Stu and Shaun go through their transition, as well as some of the local farmers, and the kind of regen stuff's my guilty pleasure. I really enjoy it. So big interest in that area. And it's great tonight to be on with Shaun to be able to share his farming practices, what he's achieved, and how we can improve soil and healthier animals at the same time.
Awesome. Thank you, Lan. I'm really looking forward to it. For now, I believe I saw Stu. He was able to get in the terminal. Are you there, Stu?
Can you hear me there?
I can.
Hi, guys. How are you doing? Sorry about that. Had a bit of a miscommunication on the flight there, and I was sitting on board and not able to get off. So I'm off now here.
Lee-Anne, first off, talk to me a little bit about your the reason why you started Ruminant Revival, and maybe the need for a paradigm shift, or the way we look at rearing healthier animals in the livestock industry.
Yeah, okay. So I suppose many of you have maybe heard me talk about this before, but in veterinary practice, we run around doing a lot of fire brigade work and putting inputs in, as in pharmaceuticals, vaccines, antibiotics, to prop up an existing system. So in conventional agriculture, yes, we have managed to increase yield. We have changed genetics to supposedly have more productive animals. We've increased day live weight gains, milk yields, and increased stock and densities. But to achieve that over the last 20 years, we've also had to develop pharmaceutical interventions to be able to tackle the health problems that result from the intensification of livestock. And we're stuck in that cycle now, that we have to find an input to solve the problem, and we are rapidly facing a big problem in the veterinary and agriculture industry, that these products are difficult to get hold of. They cost a lot of money. They don't always work because of what we've done to them and the fact that now we've got resistance to a lot of these products, and they harm the environment, and the consumers do not want them in their food. So that's 5 reasons just listed right there why we have to go back into our agricultural systems and find different ways to do things. And what's great about the practices related to improving soil health, they also improve animal health. So we get an immediate improvement in animal health just because the principles of improving soil health are the key to improving animal health. So things like rotating stock, reducing exposure to parasites, moving away from fecal material, the browsing nature, the selection within the diet, they're immediate benefits that we get straight away. And then longer term, once we get nutrient cycling and our soil's working for us, we also get the additional benefits of the trace element provision and secondary compounds and all that kind of stuff. So we've got to change what we're doing. We've got the answers, which is great, because if you went back 10 or 15 years, we didn't have those solutions, or those solutions weren't proved and practiced. We've got the answers now to the problems that we face. We just have to implement them.
And as I understand it, Shaun, you're one of those farmers that has figured out some of the ways to make it work in practice. Can you just share a few of those that Lee-Anne was talking about?
Yeah, I would say from a parasite's point of view, probably the biggest thing is short, sharp grazing. So normally a day, and then roughly speaking, it's a generalisation, doesn't always happen like this, but I would say the cows normally go into grass after it's had a couple of months of rest, and the sheep will go in after a month after the cows have been in for a day each time. So Lan can put me right after this, but in my mind, if the larvae from the worms and that are climbing to the top of the grass, and if there's only something there to eat it 1 day out of 90 or 1 day out of 60 or whatever, it's bound to be a lot less pressure on all the livestock and everything, because most of the times they'll climb to the top of the grass, there'll be nothing there to eat it, and we'll just end up falling by the wayside. So I think that's where the biggest improvement for worms anyway comes from, and I would say fluke as well. But is that how it works, Lee-Anne, or is that simple?
Exactly that, Shaun. So from when an egg lands in a fecal pat out of an animal, it takes 4 days for the larvae to hatch and climb up the grass ready to be eaten. So if you're on any less than 4-day shifts, you're moving away from that parasite challenge all the time. And the longer your rest periods, the better. So how long that larvae lasts on the pasture depends on weather conditions. So it's very, very hot and dry, it'll not last very long. But we get to this time of year when it's been kind of 10, 12 degrees and kind of muggy and wet and humid, a lot of moisture around, they'll live a lot longer. So the longer we can leave those rest periods, the better. And the other thing that's changed in your system is you're grazing long covers. So, the larvae can only climb so high up the grass. So if you're grazing a lot higher, you're going to miss those larvae all the time. Even if you did have a slightly shorter rotation in the summer, you're still avoiding that parasite challenge, which is great. And I think you'll have seen the results in your daily life weight gains when these lambs are getting challenged continually with parasites.
Noticeable how much less wormers and flukicides needed. It's we just don't seem to need it as much as we used to. That's not the reason I started doing it. I started doing it so I could feed them cheaper and have some feed through winter. But this has been like a byproduct of it, and it's quite interesting on how it's changed over the years.
Yeah, I think it's really important, and you have done this, is you can't just assume that there isn't going to be a parasite challenge. So we need to monitor what's going on. So you still bring in worm egg counts from groups of lambs just to check and verify what you're doing, that it is okay to drop that treatment. I don't think you can just assume because you're rotating and grazing slightly longer that there isn't going to be a problem. We still need to monitor and have the confidence to remove that intervention. And that's what you've done over the years. And now you know your fields, you know your rotation, you know what your lambs are doing, what they look like, and you can manage a lot more yourself.
Yep.
Shaun, do you have any figures on your decrease in pharmaceutical use?
It's a bad farm for fluke, mostly on heavy clay. Sits wet when it's wet, and well, anyway, in 2012 I got triclobendazole resistance, and in the winter of 2012 into 2013, and it was a disaster. Like, there was a lot of very poorly sheep. But after that, I used to go 3 times with fluke, twice with flukiver, and once with Zanil. And now I only go once with flukiver in a wet year. In a dry year, we don't need any fluke at all, which is, it's a bit of a relief, because I used to be quite worried that if ever we got resistance to flukiver, I would be in a bit of trouble, because the options would be getting less and less all the time. So getting on top of the fluke like that has been a big bonus with it. The worms, I used to be one white wormer always, and then about 3 times I would go with clear and yellow, or yellow, and occasionally I would go with an orange as well. Now I occasionally go with a white wormer for Nemo, but it used to be, if I only put sheep in field that had cattle in the year before as part of a rotation, I could avoid Nemo. And now it's even getting to the point where I don't even bother doing that. Nemo just isn't the problem that it used to be. It'll all still be there, and I'll always go in if ever it does rear its head. But it doesn't seem to be quite as rank as it used to. And I'll normally go once or twice with a clear or yellow. This year, I've only been once with a clear so far, but there's a handful of lambs left, and I'll test them this next week, and we might have a go with the last a yellow worm just for the last few, but we're only talking like 40 or 50 lambs. So use a lot less than we used to use. The owls, I used to give them sidectin every pre-lambing every year, and now they don't get anything at all. So that's where the big changes have been. One place I've never found any improvement is on blowfly and ticks. I still go once with click and twice with Crovect, the same as I always used to. And I actually go, I dip everything, well, all the owls, all the breeding sheep, every year now as well. So since before I started this till now, my costs have actually gone up a bit on that one. But never used to have a tick problem, and now they're kind of there in the background. 2 things for that. One, the longer covers probably don't help. And another thing, and Lee-Anne helped me get to the bottom of this, I was having a bit of problem with tick fever in lambing ewes, and what it turns out, and my dad was behind me getting to the bottom of this as well, flukiver, when you're using it in the ewes, it stops the female ticks from breeding. So it used to help keep on top of ticks. And then when I stopped using flukiver, when I didn't need it, all of a sudden that was something that wasn't giving the ticks a backing each year. So I am slightly worse off for tick problems now than I was before I started, but everything else has got better. Apart from the blowflies, it hasn't changed.
Sorry, can I jump in there, Lee-Anne? Can you just say if that's something that you've seen like a recurring thing on farms this year, or if that's something that you would suggest down to the system now?
The tick problem?
Yeah, is that something that's increasing everywhere in your perspective?
Yeah, so a lot of the environmental schemes and the longer grazing, and that's compounded the problem. So a lot of upland farms have got tick problems now, and I think when your livestock are adapted to it and you're breeding homebred replacements, it becomes a lot less of an issue. But if you are buying in stock or buying a new bull or a new tup or something like that, and they haven't come from a ticky farm and they're getting exposed for the first time, then that's a big problem. And Kyle, they get loads of ticks in the States, don't they? Ticks isn't a unique British problem. And when I was over in the States, they were they were talking about using guinea fowl as a tick mop, trying to get the guinea fowl to mop up the tick to keep it off the livestock, which is a really interesting concept. And I think I don't know the lady's name, but I think there's a farm up near Perth that's trying that on a bit of a trial basis. She's working with the Modern Institute. So I'm looking forward. I've got a friend up there who's going to feed back to see whether that's actually a success or not.
Absolutely. Yep. Yeah. I remember Luke at the soil workshop we did that you spoke at. He was saying that he was going to trial guinea fowls on his farm as well in the Midwest. Yep.
I think we just need to have a market for them. I don't know, are they tasty guinea fowls, or how are we going to monetize guinea fowl production? Enterprise stacking.
That's right. Yep. How about you, Stu? Have you found a reduction in pharmaceutical use from changing your grazing habits?
Yeah, we certainly have as well. Yeah, we've obviously been slightly lower down than Shaun. We don't tend to have the tick problems or the issues that I guess Shaun has on his, what I always refer to him as the man's land up there, with the heavy clay content and stuff. So, so Shaun certainly has the tougher end of that, and I think that's reflected in his ticks that he does get up there and stuff. But we don't tend to have that in terms of our medicinal stuff. We really do very little now, to be quite honest with you. Calves don't get much at all. The cows get one if we bring them in. And it's only because when they bring them in, we can sort of put them in the shed, and they're not on the land, so it feels like it's not such a bad thing to give a wormer. Then, other than that, on the cattle side of things, we do very, very little now, to be honest with you. With the sheep, we rotate back and forwards off our land and land we have elsewhere. So the sheep, when they do come home, probably very rarely get anything back here at our place, because we are on the mobbing round and moving and keeping them going. But when we do have them further afield, especially up at my uncle's spot further away there, they are set stocked for some of that. So they do tend to pick up those problems that Lee-Anne and Shaun have touched on, that when we do expose them to that sort of pressures, they are susceptible to it. So they get a wormer before they come back home, and then when they're back with us, they are moved around, and we don't tend to have to do a huge amount with them, to be honest with you. I don't tend to do as much feet leg counts as I probably, Lee-Anne should tell me I will. She'll tell me I'm wrong, but we tend to just to keep an eye on them, and then if we think there's a problem, call Lee-Anne and she'll help. But generally, we don't tend to have. I mean, Lee-Anne, you can correct me if I'm wrong, but we don't tend to have a huge amount of problems with it, to be honest. So.
You don't. I mean, the waiting to see what happens idea, that the reason vets advise against that is because by the time you see that they're scoured and they're dirty, the gut damage has happened, and then you've compromised those lambs already. So just to put figures back to Shaun's discussion, so we sat down and worked out his reduction in BPS products. So this doesn't include antibiotics. This is anthelmintics, flucicides, fly stuff, and including his dip. So in 2021, it was £3,152, and it's dropped to £1,900. But so it's not a massive reduction. It's dropped by a third. But in 2021, he wouldn't have been dipping, and he is dipping now. So it's kind of just balanced out a little bit. But it is a reduction, and it's a saving. Just to go back to the fluke conversation in general, so whether you're conventional or regenerative, fluke's changing quite a lot with the different climate and the different weather patterns we're getting. So fluke infection is a whole lot later than what it ever used to be. So we always used to think that the fluke infection was kind of August, September, October. And then we would have adults kind of after Christmas, January, February time. And now even in the West Coast, where it's been very wet and where there's a lot of trichovendersal resistance, and where we thought we had huge fluke problems in the past, like testing for fluke now, they haven't seen the fluke burdens that they would have done 5 or 6 years ago. But that's not to say they aren't going to see them. It's just potentially going to be later. So coming back to your testing for your fluke monitoring, you can do fecal testing, which is easy, but it only tests for adult fluke that are laying eggs. So that infection happened potentially more than 10 weeks ago. But you can also blood test first grazing season animals, and there's now a cow side and a sheep side test where the farmer can actually do that himself. It's not easy because it's like a little COVID lateral flow test kit, and you have to get a prick of blood and put it on the test strip and look for a colour change. So it's not something you do in the sheep pens on top of a hill in 40-mile-an-hour winds, but it is possible to do it to see whether there's antibodies there. And that would tell us that there'd been any fluke infection within the last 2 weeks. So that would give you a far more up-to-date kind of response. And the idea with that test is you can actually work out which areas of your farm are high risk. So when you can change your grazing management. So in the past, we always used to be like, oh, well, fluke lives in the wettest areas, but fluke can live in a cow footprint, it can live in a muddy gateway, it can live in the corner of a field. So you can't just assume that, where these fluke populations are by testing and knowing which pastures are your high risk patches, you can potentially avoid those risks. So if we did have a year where we had a really high fluke burden, you would know where the fluke were to try and avoid them, which would be a really big help to somebody like Shaun who's got triclopyrdazole resistance, because you can't actually kill an immature fluke problem on Shaun's farm because he's the one drug that kills baby immature fluke. There is resistance there, which I think has been brought in. I don't think Shaun generated that resistance. I think it's been brought in with sheep, with fluke in sheep and got established.
How serious of an issue is medicinal resistance in parasites? Is that something that, are there a big line of new active ingredients coming out, or are we running out of medicine? Like, what's the status on that, Lee-Anne? Do you know?
Yeah, so we're running out of medicines. So if you take sheep anthelmintics, the studies that were done within the last 10 years suggest that 80% of farms have got resistance to your clear wormers, slightly less to your yellows, and even more to your white wormers. And there's your orange wormers, which are the new generation wormers that came out 5 or 6 years ago. There's now resistance emerging to those as well. They've isolated resistant alleles of those in worm populations. So there isn't any new drugs. If you go over and look at what they do in New Zealand, they use a dual and triple actives, which basically means that they put 2 or more worming products in the same product. So they're basically blitzing them, hoping that, one of the 3 products that's in that bottle will kill the worms that are there. So we never want to get to that stage. But if we abuse these products, that's where we're going to end up. And we need them in our arsenal. So if we can use them if we want to use them, but we don't need to be relying on them.
Yeah, that's exactly our point of view as well. Reducing the cost of them isn't as important as making sure they're all there and all available for when we do need them.
Yeah, and that the same goes for antibiotics as well. Yeah, when there was a big push on the agricultural industry to reduce antibiotic usage, that the warning to the vets was, right, act on this, reduce your usage so you can still have them. Like if we'd carried on as we were and antibiotic levels had remained as high as they were in dairy, beef, sheep, pig and poultry, the regulatory authorities would have just said, right, you're not taking any heed of this and we're going to have to restrict your use and legislate against it. So, but that's not happened because we've responded to what they wanted us to do.
That's great to hear, because I hear that a lot in the human side of things, that we're going to run out of antibiotics that work for us. And we're going to, you see these scary statistics that 5, 10, 15 years down the road, there are going to be more and more people around the world dying from basic infection because these antibiotics don't work anymore like they used to.
Yeah, and agriculture has a part to play in that, but what happens in human medicine has a bigger part to play in it as well. So yeah, at all levels.
Absolutely.
So whilst we're on this, then let's lean into that a bit more than Lee-Anne. How much does this importance lead towards genetics? And the idea that we're going to have clean animals with nothing in them all the time is it definitely sounds like that's obviously not the right way to go. And I think we're all in agreement on that. But how much can we lean on genetics to actually help with that?
Massively. So one of the problems with blanket treatment, as you know, is that you take away the ability to select. So, if you're keeping homebred replacements and you can observe those animals and you can keep the animals that are coping with that system and are less prone to a parasite challenge and are less affected by the worm burden that they have, then, it is hereditable. So there is certain breeds of sheep where they've made that so that you can get Romneys, for example, which are, got a very good resilience to worm burdens, and they've been bred and selected that way. But you don't have to necessarily buy those genetics in. You can achieve that with your own flock by observations, daily life weight gains, fecal monitoring. And you'll have done some of that, Stu. I know you don't do your worm egg counts, but like you would have seen that in a lamb population and known it in your yows as well.
Absolutely, but people want to hear that from you, Lee-Anne, not me boring them.
All right. Yes, it is heritable. Yes, you can make significant selections. There was all sorts of technology coming out, still available, where you can measure in blood or in saliva the antibody levels to an animal's worm burden. And the idea was like you took your yow lambs and tested them all, and the ones with the highest antibody response, IgA it's called as the antibody, the highest antibody response, that they were the ones that you should select and keep in your breeding program. But again, it's quite financially, it costs a lot of money. So you could do that through observation just the same.
Yeah, so we have our first question of the night from Jet. He asks, are some soil types, i.e. acidic or neutral pHs, more susceptible to parasites? And Lee-Anne, I'll leave it to you, but here's my hypothesis. Anytime you have fresh air and sunlight, there's going to be less pathogens and there are going to be fewer parasites. So in my mind, whatever the soil type, if it's healthy, if water's cycling properly, if it's not standing a lot, and we see compacted soils, whether it be sand all the way to clay, right? So in terms of pH, that one I'm less certain about, but I'm interested to hear your answer.
Yeah, I'm not aware that there's anything related to soil type that makes more or less of a parasite burden. The more diverse pasture you've got and the better immune system an animal's got, so the better your nutrient cycling and the better your trace element provision for those animals, the less likely a parasite burden is to get established, and an animal will eat those larvae or those eggs, and their own immune system will fight that infection off, so it's not always going to complete its life cycle. So basically it doesn't really matter on your soil type, but anything that you can do to increase the number of species within your forage that they're eating is a positive thing.
Mm-hmm. So I think that's an idea that we should park on for a few minutes, this idea of getting diversity in the diet, both of plant species and nutrients, micronutrients, phytonutrients. So maybe that's to tee you off, Lee-Anne. Why is it so important to offer livestock a diversity of plant species in their diet?
So there's lots of reasons. So whatever they eat is reflected in their rumen microbiome. So similar to ourselves, we each have a microbiome, our bacterial population, protozoal, fungal population, which is in our stomachs and in the rumen of a ruminant, is dependent on what they eat. It's also dependent on breed, age, genetics, sex, all that kind of stuff. So the more diverse a diet, the more diverse the rumen microbiome and the more resilient and richer it is, and feed conversion is better, and the rumen is healthier, and everything functions better. So if you think about your rumen health is vital, because the only way ruminants do what they do is they take an indigestible product, which is the lignified cellulose containing grass that a simple stomached animal like us ourselves couldn't digest, and the microbes within the rumen basically make that into a utilizable energy source, so by releasing volatile fatty acids. If we don't keep that rumen happy and the microbes within that rumen happy, then that doesn't work. So that's a massive thing coming down to efficiency. In terms of if you take it back a step, just thinking about the behavior of those animals, the free choice they have to select what they want to eat is a huge thing in terms of dietary selection. And getting back to Kyle's reading Fred Provenza's book at the minute, Nourishment, and that's hugely mentioned in there, that these animals have a natural ability to be able to browse and choose what they want, and a lot of that is them looking for secondary compounds. So day to day, as in conventional agriculture, vets and farmers and nutritionists are obsessed with protein and carbohydrate and fiber content and all these percentages and how it all needs to be balanced, which is important, don't get me wrong, they're the primary nutrients, but we have loads of secondary nutrients as well, which we need for some of them are medicinal, some of them are natural anthelmintics, and some of them are kind of antioxidative as well, which help us with metabolic and physiological stress. So the ability for the animal to select what it wants to eat is a big thing. And actually there's research to suggest that actually that makes those animals happier. They're satisfied in their dietary needs. So people would laugh at that and think that's really funny, but I certainly would like to choose what I eat. And there's research to suggest that animals do as well, in terms of they like to browse hedgerows, they like to have a choice, they like to have a enriched environment. So there's lots of reasons why biodiversity is important, and in the long run, you know, if you have got really good nutrient cycle and you are managing to break down that compaction, that soil biology is working for you, then you are going to be able to bring some of those nutrients up into the forage that exist in your soils, and that's going to ultimately, in the end, decrease the need for external supplementation and artificial trace elements. That again is another input into a system.
Yeah, I know we talked about it on a past episode, but I think it's important to touch on that and define exactly what are phytonutrients, right? And what are secondary compounds. So you mentioned the macromolecules, the primary compounds of proteins, fats, carbohydrates, and then genetic material, obviously. So that makes us up. I think of those as like, if you're building a skyscraper, that's like the skeleton. You know, that's like the outer, the girders, the beams, all that stuff, right? But it's what's on the inside, the finer things on the inside that really matter and make the skyscraper function and what it is, right? And for me, that's what those secondary compounds are. And so when we say the word phytonutrient, phyto means plant, nutrient means obviously nutrients. So these are secondary compounds that the plants are producing for special reasons other than just their main body structure, right? So like Lee-Anne said, you know, some are for different reasons, for health and wealth reasons is what I call it. So like anti-inflammatory, some of them are even for sunscreen, deflecting UV radiation. A lot of them are to resist browsing. So when a plant's not ready to be grazed, it'll produce a bunch of phytonutrients that are often toxic in certain quantities to the animal. So, but here's the thing is a plant is not a plant when it comes to phytonutrient density, right? So one chicory can be completely different to the chicory next to it, and one plantain to the next plantain, right? So what I've learned from the book and Fred Provenza and all the smart people that I get to hang around is it all comes down to the microbiological activity in the soil. So, you know, if we're trying to improve the phytonutrient density of our forage, it's the same as the phytonutrient density of our foods, of our fruits and vegetables that we eat, right? And then that ultimately translates into the meat and milk that we get from our livestock. But really, if you don't have a functioning soil microbiological fire and engine down there, they're not going to be pumping that energy to then create the compounds in the forage for those plants to produce those secondary compounds. So it's not only getting the diversity of plant species, that's great. That's the biggest step. But then again, not every plant, one plant might be way unhealthier than the other. So the more you build soil health, the more it rises that phytonutrient content of everything, and then they balance out. So, you know, issues of toxicity, whatever plant you're talking about, or you know, like bloat, for example, those problems are much, much less of an issue when you have diversity of nutrients that can neutralize each other in the rumen. I think what is it, Lee-Anne? Condensed tannins in the sandfoin and the bird's foot trefoil can knock out some of the dangerous alkaloids that animals might eat.
Yeah. And I think everybody gets het up about diverse pastures and hedgerows and poisonous plants. The animals don't choose to eat those plants if they've got a choice. So if you look like things like rhododendron poison and things like that, they'll only go and eat rhododendrons if there's snow on the ground and they have no other choice of anything to eat. And the same with the acorn abundance that we've had this year. You know, they don't necessarily choose to eat, you know, if there's an alternative, something else that they could eat. You know, they are smart in that respect. So yeah, I mean, that's a fantastic description of how, you know, soil biology can massively affect not only the animal health but our human health as well. And they've proven that very nicely with milk constituents as well, from secondary compounds and tannins coming through and all that kind of stuff. So yeah, it's a massive area of research that probably hasn't been taken to fruition yet.
Yeah, and I even think about our food labels on our food. You know, they only talk about the big macromolecules and a few vitamins and minerals, but it's really those health and wealth compounds in our food that keep us healthy and wealthy, right? So we need to be offering that same thing for our livestock, because it's not just something that sounds nice and we want our animals to feel better. It's how you run a more profitable business at the end of the day, you know. And Dr. Alan Williams, he often talks about like cellular memory and the epigenetics. And so when you provide your herd with more of those nutrients that they crave, some of them are their genetics are going to get tapped into, and they're going to become better performers, and they're going to become healthier, right? And like Stu was saying, those are the ones you want to select for. So then it's kind of like you're rising the rising tide raises all boats, right? So you're rising the soil health, which rises the plants, and then it rises the animals, and then you're choosing the right animals that fit the system. You know what I mean? So that's really, to me, what this whole regenerative thing is about, talking specifically in the livestock sector.
Shaun, do you want to add anything in there in terms of your herbal layers and stuff that you've been using? Are you seeing a huge improvement in like, I know people talk about cobalt deficiencies and stuff like that, especially in your area. Do you have huge issues with that sort of stuff?
Yeah, we still have an issue with cobalt, and I can't see that going away. Partly because we're not really feeding any cake anymore. You used to get cobalt in wheat cake, and you never used to realise you were getting a lot of stuff in wheat cake. And now that it's nearly everything's done with grass, still do a bit of finishing with cereal. Like the only place where stock can get any nutrients, that's from the grass now. And actually, cobalts are something we have to keep an eye on now. But most other things, much better on a herbal layer than it is on a normal grass field or a permanent pasture even. The stock are noticeably thrivier, noticeably more settled. And when you first take them out of a herbal layer and put them back onto a permanent pasture field, it takes them a day to, for them to settle down onto it, just because they like the taste more, and they do better on it. Yeah.
On that subject of cobalt, something that Stu and I often come across is the idea that willow trees can hyperaccumulate it, and that can help out with cobalt deficiency in lambs.
Yeah, probably.
But this is But this is the question for the group. If our soils are deficient in cobalt, where did the willow tree get it from?
Yeah, Stu raised that with me the other week. Yeah, very good point. It's there. It's just, it's getting taken up into the willow, and it's not getting taken up into our grazing land. So what different microbial population, or what is happening beneath the soil, and the relationship between that willow plant and its symbiotic relationship with its microbes that's different to anywhere else. I don't have the answer for that.
Willows are funny, aren't they? They aren't even like normal trees, never mind like normal grass. So they do a lot of things different to other plants. Like.
Mm-hmm. And I think from a pure soil science standpoint, that subsoil, that zone of accumulation, you got to think that gravity over time, and we're in a climate where it's very wet, and that leads to a lot of leaching down into the subsoil zone of accumulation. So if we don't have roots going deep, and they're not actually accessing, they have no chance to access all of those nutrients that have leached into that B horizon, that subsoil. If you have subsoil, then you have no chance of bringing up those micronutrients from down below. And maybe that's simply what it is with the willow. It's just got deep enough roots that are down there accessing the cobalt and then bringing it up to the leaves. I don't know, but what I do know is I've been in enough pastures over the past few years to know that the vast majority of roots are very shallow. And I think there's just a whole treasure trove of nutrients down below in the soil that just aren't being tapped into. That's my theory, at least right now.
Shaun, I was going to ask, have you noticed any grazing patterns when you put them into these herbal layers? If they sort of target specific plants more than others, when you do put these lambs per se, you can notice how they browse and graze. Do you notice any difference in those sort of livestock when they're grazing?
Yeah, nearly everything go for the herbs first, out of choice. When you first put them in, then an hour later they set on and eat the grass and the clovers and that. But it's nearly always the chicory and the plantain that they're nibbling at first, which you saw that day you were here, didn't you, Lee-Anne? The cows, yeah. They just went round it all first. And
it was so funny with the cows, and there was one cow, and she just went on a complete mission. She just took the head off every single chicory plant, and the chicory was just about to flower, wasn't it? So it was, yeah. It was significantly higher than everything else, and she literally bashed everybody else out of the way because she was going for the chicory. That's what she wanted, and she was on a mission.
Yeah.
To me, that's back to that idea of nutritional wisdom. that she must have needed some nutrient that the chicory was offering at that stage in its life, right? So Fred Provenza's book Nourishment, I'll shout it from the rooftops. I think everybody needs to read it at least once in their lives, especially if you're in the livestock industry. But there's this wisdom, there's this feedback wisdom in all of us, humans too, but especially our livestock, right? So the basic tenet is that if it makes them feel good, they'll remember that and they'll eat more of it. And if they're getting a diversity of phytonutrients and micronutrients, it's going to make them feel better. So they're just going to learn that to eat it, oh, this is good for me. Boom, boom, boom. And Stu, you've even talked about your cows. They go for thistle now. Who would have thought that, right? So with those deep tap-rooted herbs, weeds, forbs, whatever we want to call them, I simply think that their deep tap roots are able to access more of those micronutrients, possibly produce some of those complex phytonutrients that might be anti-inflammatory or anthelmintic, and it makes the animals feel good when A, they're offered it, and B, they learn to eat it, and it makes them feel good. On that, Lee-Anne, are there some general deficiencies of micronutrients that you see in different parts of the countries, and how have you seen those remedied with a more regenerative, diverse pasture grazing?
Yeah, I have yet to see, other than probably Stuart's farm, the farms that nutrient cycling sufficiently that they could remove trace element inputs from an existing system, certainly in lamb growth and sheep production. So I think we've generated these lambs genetically, which are very, very fast growing. And I think that requires trace elements to achieve that. And although we're changing the systems, we've still got those high day leg weight gain lambs that have a bigger demand for cobalt. So cobalt is all to do with energy. So they once they've become a ruminant and they don't have the lactose supply from the milk from their mums, rumens for their propionate cycle, they require cobalt for that to happen. So I think it's something we've got to be really careful of, just because again we've gone regenerative doesn't mean we can just pull all those inputs out. I think systems do fall flat on their face quite quickly, and I think trace elements is one of the last things that we could withdraw from those systems. We just have to monitor using blood samples or potentially liver samples from dead animals where our trace element status is until we can remove those inputs. Stu hasn't never had a massive problem with cobalt selenium deficiency, but this area, so the Northumberland kind of Tyne Valley and up into the North Tyne, has always been famously deficient in cobalt and selenium. I think copper deficiency is a lot less than what it ever used to be. Not through regenerative practices or any change in grazing. I think just that things are changing, and copper's funny because it's not just how much copper you're feeding an animal, it's antagonized by iron and methionine and sulfur, and there's a lot less sulfur around. So that it's an interaction type thing. So we don't see the cases of swayback and things that we used to see 20 or more years ago. So copper's a funny one, very farm specific. The antagonists make it very difficult to predict whether a farm's going to be copper deficient or not. So you can't generalize on that. I think sometimes we see lambs that the farmer thinks is swayback, so they're going off their legs, and when they're 2-3 weeks old and they're dragging their legs around, the farmer's like, oh, I've got swayback, I need to copper my yows. On many occasions that's actually a joint ill infection that's gone between the spinous processes of the spine, and it's pressing on the spinal cord, and that's paralyzing the lambs. So it's really important to get a post-mortem to work out whether it's been a bacterial infection and it's delayed onset joint ill, or whether it's actually a true swayback, because obviously copper supplementation can be toxic.
And what's the reason for the reduced sulfur? Is that from the scrubbing of the smokestacks and everything?
I think it's fuel's changed, hasn't it? Like car fuels and things like that have a low sulfur. The other thing to watch out with copper is because iron's an antagonist. If you've got a lot of soil contamination, that will lower your copper levels, because the iron in the soil is antagonizing it. So again, like longer grass grazing and not grazing down with a lot of soil contamination will help copper levels.
Very interesting.
And I'll just jump in there, Lee-Anne, as well, if you don't mind. In terms of the you were talking about the modern genetics, and I don't want to keep harping back to genetics, but the big fat lambs that have that cobalt demand. Are you suggesting then that the likes of the Blackie and the Hill lambs, sorry, they don't have that demand as high. Is that what you mean there?
That's a really difficult one because they're probably grazing the poorer land, which has a more of a trace element deficit, I suppose. So they still do require supplementation, but is that because they're on the more deficient land, or if you put those lambs in a different system, what would it be? So I don't know the answer to that question.
I was wondering how much we'd wreck sheep, Lee-Anne, you see, and I was hoping you were going to give us a definitive answer there, but
I don't have a definitive answer, but I do think we're achieving very, very quick growth rates in lambs compared to what we did, in the past and the previous generation before us lot, really. Selenium's a big one. So when we talk back about your phytonutrients, so selenium is linked to oxidative stress. So oxidative stress is something that we don't really talk about, but any stressful procedure that we put an animal through, so handling, dehorning, carving, transportation, sales, that has like a physiological stress response on the animal. It releases cortisol, and they produce oxidants which are harmful to their cells. So you have natural antioxidants within an animal, which can be enzymes or non-enzymatic. So your enzyme antioxidants, they require selenium. So selenium is very much put forward as an antioxidant, kind of like protective trace element. And so in the pharmaceutical world, that's why they suggest selenium injections and selenium supplements like before vaccination or at weaning and things like that, is because selenium is an antioxidant. But getting back to the discussion we had on phytonutrients, all your tannins and your phenolics and your terpenes and all that kind of stuff, they are also they're non-enzymatic antioxidants. So they provide the animal the ability to neutralize these nasty oxidants that are causing a lot of stress to the cells in the body. So and like I've just mentioned, some of the management practices that we put animals through in terms of the physiological stress, but it can also be metabolic stress. So like a disease incidence, or an animal that's got a temperature, or it's had mastitis, or and to be honest, heat stress is one of the big things that we probably don't really acknowledge. And we think, in Britain it's always raining all the time and it never gets particularly hot. Like there was days last summer where and you guys would see it in your soil temperatures and obviously the bare ground that was around, but those animals on that bare grazed pasture, they are at the extremes of what they can tolerate in terms of what they're comfortable with, and that's a huge stressor on them as well.
Is there something to be said for like subclinical inflammation? Like I hear that a lot when on podcasts with medical doctors for people, right? Is just how crucial it is that so many people have this like low level, chronic, constant like level of inflammation in their bodies. These oxidants aren't being flushed out by the antioxidants, and that leaves us with so many issues and risk to disease. Is that kind of what you're saying in the livestock as well?
Exactly the same. So when you read the human research, if you think how narrow the diversity of the human diet is now with the ultra processed food and the amount of like sugar and starch that we're eating and the lack of fiber, like all that is exactly the same. So that's causing low grade inflammation, that's releasing oxidants. We don't have enough antioxidants. Yeah, all the same happens in livestock health. And that they've also, highlighted the link between our gut health and our mental health, and they haven't done the research in ruminants to suggest that link is there, but it is in pigs. They've done, that's the only livestock pig kind of species that they've researched it in. But how they're assuming that the volatile fatty acids that are released from our guts, which in humans is our hindgut, because we don't produce them from our stomach because we're a monogastric animal. But in ruminants, there potentially is a link between the volatile fatty acids that we release from our guts and how that affects our mental state. Your gut-brain axis, as it's called.
Thank you very much for that. And we have a question from Mr. Niels Corfield. If we want to touch on that, he asks, can we speak to the efficacy of resilient Romneys or similar breeding programs in terms of their performance in high pressure environments with no treatment, and to what extent farmers could do the same for themselves?
So that's the idea. I can't see the question. That was a very long question. so Niels is saying that we haven't got any selection pressure on those animals once they're in that system because we haven't got a worm burden. Is that what Niels is getting at?
I think it might be. Yeah. Yep. Niels, if you want to clarify yourself there, but yeah, I essentially that's what I think it is. So, is there a program called Resilient Romneys? He's capitalized it, or is that just an idea of breeding more resilient Romneys?
I think Romneys have famed themselves. I'm not aware of the Resilient Romneys as always got as a brand. That's interesting. There is other breeds of sheep that have marketed themselves in that way as well. You know, for example, some of the Innovis guys have, and the Easy Cares and things like that. So the thing with that, your genetic component to worm control isn't everything. It's just a small part of a bigger picture. So it helps. And they won't be, it's not that you would worm egg count those sheep and they would have no eggs in them, but if you challenge them with a worm burden, they wouldn't, that worm burden wouldn't become established, and therefore they wouldn't be the kind of egg multipliers that a normal sheep would be. So they're a bit more of a dead end host than what a normal, for example, a lamb with no immunity would be to a worm burden.
Okay. Understood.
We'll never get rid of worms. We will have to live with them forever. We wormed since we were using zinc sulfate and copper sulfate back in the 1940s and 50s to control worm burdens, and we've still got worms. So we'll never get rid of them. It's just as long as they're not affecting our production, then we can live with worms. That's okay. We've just got to be able to manage them without chemical interventions.
Lee-Anne, now, as I understand it, you have a book you've written on topics such as these. Is that correct?
Oh, crikey me. When I wrote the veterinary book for beef farmers, which came out about, it was the middle of COVID. So even since then, things have moved on quite a lot. So that book is divided into two halves. So the first half of the book is how we would manage the environment and husbandry to avoid disease. And the second half of the book is, well, if you've messed up, so if you've got your genetics wrong, your management wrong, and your nutrition wrong, these are the diseases that you will see, and this is how to treat them. So the book was always written in that kind of context, that it is possible to minimize and reduce the risk of all these diseases if we got things right, but we don't always get things right. So then we have to, manage the catastrophes that we create from that. But I think since that book was written, even things have moved on massively. I mean, this chat that we've had tonight about integrated parasite control, we haven't touched on the active parasite stuff, but the stuff that we've talked about phytonutrients and trace element provision, oxidative stress, rumen microbiome, diversity, that stuff even 5 or 6 years ago wasn't in the mainstream as much as it is now. The book that I wrote was scientifically referenced from papers, and we're still lacking some of the scientific evidence in peer-reviewed published papers on a lot of this stuff, because there isn't the funding behind it like there has been in the past for the development of pharmaceutical products.
Bingo. I think that's so true. I was thinking about that the other day. How many billions of dollars have been invested, probably even up to the trillions, in the current system, whether it be the healthcare system, veterinary system, and we know so stinking much about it, but we've invested so little time and energy into the stuff we're talking about today. And just think, like, I'm encouraged by what the universities are studying, some of these PhD works that I get some emails from folks at different universities, and they're doing amp grazing research as a PhD student, and they're doing phytonutrient density in forages and soil microbiome. So I think in the next 5 to 10 years, it's only going to accelerate in our knowledge, and we're going to be able to use this to run a profitable livestock farm or any farm of any sort.
Yeah, and I think the drive for that to happen is the need for sustainability, because we've actually realised that if we don't do something, we're not going to be able to produce food in the future. So that's now become the kind of panic driver, rather than it being a product for sale that somebody can monetize.
So I just want to say, I think we have a half hour left. So if anybody has a question on their farm, if they have some observations, please throw them in the chat. We've got some wonderful resources here, and we can answer your questions. But Lee-Anne, you mentioned ectoparasites. Did I hear that right? We haven't touched on. What would that be?
Yeah, so Shaun mentioned before a blowfly, that he hasn't managed to decrease his tumours for blowfly. And And I worked with a farmer this summer who has just started mob grazing, and he's got his cattle and his sheep in together. And it was just a conversation that came up that every time he moves his cattle and sheep, he has his own kind of population of birds that you almost wait for him to come out to move the fence and move the cattle and move the sheep. And he's dropped all blowfly treatments this year. And so he hasn't dipped, he hasn't applied any Crovect or Click or any Porons to his sheep flock at all. And he wouldn't usually apply stuff to his cattle anyway. I mean, he's had no cases of blowfly this year. And I think that's really significant, that the bird population of obviously you're picking up the larvae for the blowfly out the fecal pats and reducing the challenge to those livestock, and I think that's just really cool.
Yeah, that happened here, but then the sparrowhawk realised that if he followed the cows round as well, he got a lot of little birds. So, moving both together, does he not miss out on an opportunity to use like cattle as a dead end host for sheep worms and vice versa?
Yeah, that's a very good point. Yeah. In a set stock system, that would work, co-grazing, because like we said, it takes 4 days for that larvae to get onto the pasture, and then they would get hoovered up by a dead end host. But moving everything together, because he's doing daily shifts, you would lose out on that benefit. Yeah. One of the things that obviously to encourage bird population on farm, you need trees. So, there was a great big discussion about, we could plant some more trees and some more hedges to encourage the bird population, and that would help control the blowfly population. But traditionally, farmers see running water in trees, which is what encourages bird populations, as a blowfly population. So if you were, for example, drying off some cows and you didn't want them to get some mastitis, the last place you put them is in a sheltered paddock that's got trees and a river next to it. So we were talking about that, and you guys will be able to, this is kind of beyond veterinary medicine really, the reason that potentially watercourses attract flies is because we've actually got a broken ecosystem in that respect. So our rivers aren't functioning properly, our water health isn't very, very good. So we've got a biased invertebrate population and a non-functioning ecosystem within our waterways, which is why we're getting a predominant blowfly population. I don't know what there's no evidence base behind that whatsoever. I'm just extending the chat that I had with one of my clients to you guys for you to see what you think.
I think there's probably a link there somewhere. I don't know enough about that to suggest if it's, like, as you said there, it's probably a lot of conjecture sort of thing, but at the same time, there's obviously a link there. I think what's more prominent is, you talk about an imbalance in the invertebrates, is that we don't have necessarily a lot of places don't have the dung beetles and the invertebrates that's in the manure breaking it down really quickly, which then allows the flies to get in there, create their home habitat, to then multiply up and incredibly quickly. I remember being in America and walking around some of the fields there, and they have a insect population that's it's quick, and the manure's barely touched the ground, and then there's dung beetles there, and it breaks it down phenomenally quick. It's a different environment, completely different dung beetle types and all that sort of stuff. So I'm not going to compare apples for apples there at all, but I think here we have much slower. It takes a lot longer, and it's basically just opening up that opportunity to allow these fly populations to really burst, I guess. Kyle, do you want to add anything to that?
No, I just think anytime you have stagnant cycles of any kind, whether it be water, air, nutrients, you're going to have more pathogens and you're going to have more parasites of any kind. Really, that's really my main takeaway. Ben asks in the chat, actually, on that topic of trees, have Shaun or Stu ventured into agroforestry or improving their hedgerows to increase browsing for their animals? Shaun, we'll start with you.
No, not yet. I'm not a fan of trees in the middle of fields to plant a load of them, but I do know Stuart's done that, so he's going to say I'm wrong. But I would like to see the field boundaries all put back to proper hedges. But I've got a couple of other big projects on the go, and it'll be when I get finished phase that I'll start on that. But yeah, yes, yeah. I like trees and hedges around the outsides of fields. Not a fan of them in the middle of fields, and I certainly wouldn't like to plant a good open field full of trees. But are you seeing an improvement from it, Stu? Or?
I guess my trees are fairly in the infancy stage still, in terms of, I don't think I'm getting a huge benefit from them, yes, but I I have been to many farms that you see a huge benefit from the trees being there, to be honest. One thing I will say is that I remember putting in one year a really diverse multi-species whole crop mixture. And I was going to whole crop it, and then I thought, no, do you know what it is? You know, modern man and all that, and I'm going to try and do some grazing of it. So I put animals in to graze it rather than putting the machinery through it. This was in the early stages, and I watched as they went through this really expensive mix I put in, and all went and stood and ate the hedge. And I remember thinking, I don't know why I bother in terms of why I've gone to all this trouble. And when the animal, like you said before, with its nutritional wisdom and all that, makes a beeline for the hedge. And that was in the time when I didn't know enough about it to understand why. But it was frighteningly obvious as to where they wanted to be, and it was not in the crop that I was putting in the ground. So when I saw that kind of triggered something in me, and I thought, well, why is that? And then a lot of the time you sort of look at it and you think, well, a lot of the stuff I put in there's annuals, shallow rooting, isn't necessarily got the nutrient density, say, that the hedge leaves will have. So watching them make a beeline for that shows that they wanted to be there. They had something there that they needed, and they made a beeline to get there. So it's maybe not as exciting as it could be, but it's relevant when we're thinking we are forcing animals to eat sometimes stuff that they don't necessarily want to eat. So, and on that happy note.
Yep, a lot of noise there at the airport, so Stu's going to mute himself. Thanks for that, Stu. Jet asks, is parasitic burden different between organic and non-organic systems, or is it an area that isn't researched? Does anybody know? I personally don't know. I mean, just thinking about like the pharmaceutical uses that have the unintended consequences of killing potentially invertebrate predators in the soil and the dung beetles. I don't know. That might have an effect on parasitic burdens, but that would be my only guess. Lee-Anne, you probably have a much more educated answer.
I don't think you could generalize and say that they were worse or better in either system. It would depend on your management. So if you potentially on your organic system, if the weather was right and your grazing management wasn't spot on and you had susceptible animals in the wrong place at the wrong time where there was a lot of larvae, you would still see worm problems. If you'd been organic for a long time and been very careful with anthelmintic usage and followed all the Scots principles and not developed your resistance from your anthelmintic products, you would still have products available to manage that burden. I suppose that would be a big plus. And then I suppose getting back to Stu's point about dung beetles, if you've been repetitively using anthelmintics, especially your clear wormers and avermectin type groups, then you won't have a very good dung beetle population that's particularly active. So therefore you'll have a lot of fecal material on top of the pasture, and as a result, you potentially have more parasite problems, whether that be blowfly or gutworm or whatever else is going to live in those dung pats without the dung beetles to disrupt the pat. So yeah, I suppose that question is a really open question. I don't have a right or wrong answer to it, really. It's up for discussion.
Great. Thank you, Lee-Anne. Casper asks, you spoke earlier about free choice grazing. How do you manage that when AMP/mob grazing? So, Casper, I suppose this is more about the animals being selective in what they're eating. Maybe that's how I'm taking it. And so, yes, he said, all right. So from what I've learned, a lot of that has to do with stocking density and the pressure that they put on themselves. So the more space they have, the more selective they are. The tighter that you group them, the more, especially cows with their swooping tongue, they tend to incidentally eat more diversity, and they're less selective or non-selective. That's really, I guess, how I'd answer that. Shaun, do you have any more insight on that?
How selective they are, like you say, density and how much you make them eat. If you leave in half of it, then some stuff will eat down to the ground and other stuff will still be fairly long. So that's a bit of selective in among it, if you see what I mean. If they're eating everything down to the ground, then they're not selective. But if you're only taking half or taking a third, then they can be selective about what they eat a lot of and what they don't eat so much of.
Mm-hmm. Yep. Now, Lee-Anne, we're talking about giving them the choice to eat diversity. So I could see some people say, well, that's a little contradictory, because if you tighten them up, then they're non-selective, then they're not going to eat that diversity. So have you ever gotten that question before from a client?
No, I don't think I have. I suppose the diversity is available to them, though, isn't it? That's the difference, that they would have a choice if they could have a choice. And I suppose the extreme of that is, if you were feeding an animal, for example, a TMR ration, which is what would happen in conventional agriculture and production systems. Any population is a bell-shaped curve, isn't it? So if you're formulated a TMR ration for that 650 kilogram animal that's producing 20 litres of milk, or that is grown by 1.5 kilos a day, the only animal that actually perfectly suits is probably one or two animals in that herd, as much as it's a bell-shaped distribution. So it will be wrong for 98% of the animals that are fed that ration. And I suppose that's the beauty of grazing and diversity, is that they do have that choice, and we're not forcing them, unless we're, like Shaun's just said, you're expecting them to eat very quickly, or pushing them down to leave a low residual. And I think that's, even if we get away from TMR rations and go to things like bale grazing and things like that, is not forcing them to eat everything that we put in front of them and leaving some behind, and that's okay. That is a level of selection, and then having some ability to choose what they eat. With
that whole mob grazing, when we do put them in at a certain density, a lot of the time it's about training those animals that they can eat some of these plants, because I think sometimes they've never wanted or needed or tried even a dock or a thistle or a nettle or something like that. And once we put them in tight and that sort of mob mentality kicks in, they actually will take a lot more of these plants that they didn't realize they could eat almost. And I remember watching Dr. Alan Williams over in America actually train some cows to do that in a 20-minute period to make them eat some burdock, I think it was. And it was really fascinating watching the farmer say, well, they'd never eat this. And then, actually, I think you were there, Lee-Anne, weren't you? And then,
they trampled some of it and ate some of it. I thought what was really cool about that, actually, we did a high intensity stocking kind of exercise for 20 minutes, and the real key to that was that it was the right time of year, so that burdock was really lignified. So when they did tread on it and snap, and it went over, it didn't just pink up again, and it actually snapped. So by a combination of eating it and trampling it, that it was really effective. By the time we went out of that paddock, it was, it wasn't an obvious, weed, let's say, undesirable species in the grazing area that they just left.
The stock are noticeably healthier grazing like that. They don't seem to take illness quite as much as they used to, if you see what I mean. So it must be helping them. Don't seem to get the problems or need the interventions that they used to, like odd ill ones and stuff like that. Doesn't happen like it used to. And certainly don't spend on antibiotics like it used to.
So, Shaun, I have a quick question for you, maybe as we start to wrap things up here. So, we talk a lot about the taller grazing and getting the diversity of species and the benefits that brings to the soil. And today we've talked about the benefits to the animals in terms of health and phytonutrients and all that. But, in farming, we have to make compromises a lot of time, and especially with the more higher performance demanding animals. Been doing quite a work with dairy cows recently, and there are certainly compromises that have to be made within this whole amp grazing, taller forage grazing system, right? With a performance animal like a lactating cow. In your experience with something like lambs, for example, how do you strike that balance between soil health, doing the right thing, but also maintaining animal performance?
Go back quicker with the lambs. Go back when it's lusher. So, roughly speaking, that's sort of 4 weeks after the cattle have been in. It's from a soil health point of view, you would want it to be 8 or 10 or 12. But from an animal performance point of view, the 4 weeks after the cattle have been in tends to be when the sheep do the best. And so you're going when it's lusher, just for the lambs. It's not for the soil, it's for the lambs, if you see what I mean. When it's dry, you can get away going into longer stuff, and they seem to do all right. When it's wet, it does need to be a green lush leaf for them to thrive. When it gets stalky, they don't seem to do when it's wet. So it's you keep going in what would normally be considered too soon, but it is what's best for the lambs.
And so how would you follow up that paddock the next time, knowing that you went in too soon, quote unquote?
Too soon, you would leave it a long time, then go in with cows. So leave it a couple of months and then go in with cows after that. Cows, are fine as long as there's plenty there. It doesn't seem to bother them, but do all right on it. So you can leave it as long as you want, and they'll do well on it. But use the cows to graze it and mash it all down. And when it comes back lush, and then it's right for lambs again. Like so, that seems to be what works the best. It doesn't always happen, like, and it relies on the balance between cattle and sheep being right. If you were all sheep, I would say it'd be pretty hard to manage it and have the soil health improving it to be great as well. You would have to compromise more on the soil health, I would say, to get the animal performance.
Yeah, I'm just going to jump in quickly there, if that's all right. So on that front, we're talking, there's obviously a carbon nitrogen ratio in there, and I always love wheeling Lee-Anne out here to discuss this, because the carbon nitrogen ratio that we find so important in the soil is also really important in the animal. And obviously the play part in what we're making the meat actually has a huge impact on the health of that animal going forward. Can you just really break into that a little bit, Lee-Anne, in the last 11 minutes? I'm glad I've left it this late to bring this topic up because it's quite a big one. But that whole carbon nitrogen ratio and how it's so important within the animal and how that impacts on whether you've got short-term keep animals or long-term keep animals and that sort of stuff.
Yeah, so I mean, this is kind of conventional science as much as when an animal eats, food goes into the rumen and we need sufficient protein in there to feed the rumen microbes. Any excess protein that goes into the rumen that's not utilized is absorbed and it goes to the liver as ammonia and it's turned into urea. So that is a bypass product. So I'm sure when you've been over doing your dairy cows this last week, there's been a lot about chat about milk ureas and blood ureas and all that kind of stuff. And that's a waste of nitrogen, which is expensive. So when cows go out to grass in the spring, you very much see that, there is very, very high protein levels in the grass, and therefore we get a lot of urea produced, and that's a waste. If we have sufficient energy in the rumen we need sufficient energy going into the rumen to capture as much of that protein as possible. So we're not wasting it because it's costly in a conventional system. That's a feed input. And that's cost a lot of money because protein is expensive. But even if in a forage-based system, if you can match your energy and your protein, so you're utilising as much of that protein as possible for production, which in dairy is milk yield, that's what protein drives, then you're maximising your efficiency. But where blood urea, if there's excess urea in the bloodstream, some of the things that have been talked about, and again, maybe not a strong evidence base to prove it, but that can affect things like the uterine environment, which can potentially affect conception rates. And the big chat that we had when we were over in the States is how that could affect such as like your tear film pH, which made the eye more vulnerable to infections. And they talked about a lot of pink eye, and that happened in the spring when the grass was really proteinaceous. And we were kind of hypothesizing that could be high protein levels causing a different pH within the tear film and therefore predispose them to infections, because their solution to their pink eye wasn't to reach for a bottle of antibiotic. It was actually to put out some bale grazing. So they were therefore giving them fibre, slowing down their rate of digestion, giving them some more carbon, giving them more energy to be able to utilize that protein better. So they didn't have the fluctuations in blood urea and ultimately milk urea that they would have had otherwise. So that's the whole how the rumen functions. So what was there any chat about that when you were over in Ireland? Because obviously they're space systems over there with more grass than what we could ever imagine.
Yeah, I think I was trying to link it. Well, yes, it was mentioned quite a bit, and then I think I was trying to link it back to a bit there with Shaun's sort of thing that often we we can force an animal, shall we say, with the protein, and like with the fattening lambs and stuff like that, and it's absolutely, short term we can do that, and we do that, and a lot of people I know do that, and I don't think there's a huge issue with that. I think it's if you go and I think a lot of people would sometimes run their ewes over something like that, and I think if you do that long term, it sort of brings in a bit of an issue, much like it does with the dairy cow. Sadly, that's I'm trying to think of a nice expression through the eye of the needle, shall we say, for the whole time, which is putting them under a huge amount of stress, which is kind of where some people force that diet on them a lot, and that sort of ramifications is that we have an animal under stress that then comes under a lot of ailments, shall we say, as well. So that's very prevalent in the dairy section. So it's just why we see such low numbers and low lactation cycles and all that sort of stuff. So you'll probably know more about that than I will, Lee-Anne, I have to say. So.
Just under a phenomenal amount of stress as a production animal, really. And I mean, that you could extrapolate that to say that was your fat cattle in a shed that you were trying to get finished on a TMR ration. Their ruminants need to be balanced. How even really basic stuff about like how they're fed, how often they're fed, bullying within the group, feed space, lying space, and really importantly, actually water. And that is actually one of the things that we forget about when water quality is really, really important for rumen health. And generally in a regenerative system where we're mob grazing or we're moving cattle, one of the really, really good things is the water is usually really, really clean. Because you're seeing it every day and you're moving it every day in a set stock system. If you go to a water trough in a field, it's pretty manky, and a lot of shed systems, especially with like straw blowers nowadays, they're contaminating the water trough, and water intake is a massive deal. So I think going back to your point, any production animal which is being pushed out with its normal realms of production is stressed.
And then, tying that back into human health, I've read that the last month of an animal's life is extremely important in terms of the nutritional quality of the final product, right? So, even that has an effect on us in the meat and milk that we're eventually getting and creating our cells with. So,
well, all those antioxidants that we talked about before are held within the intracellular structure of that animal, which is then actually what we're eating. So if you are stressing an animal, and using a lot of those antioxidants up to neutralize the oxidants that are being produced, the free radicals that are damaging those cells, that's going to be less. There's going to be less in the meat when we come to eat it, which affects everything. It affects how it sets, how it rigors, how it hangs, how it tastes, and everything beyond that.
Wow, that makes so much sense. I'd never heard it explained like that, but that makes so much sense.
It's pretty cool. I love it. It's great stuff.
Mm-hmm. Mm-hmm. Well, we have about 5 minutes here, so I say we start to get wrapped up. There are just 2 more questions that I can see, so maybe we can touch on those and then say our final goodbyes. So Steve said, I read somewhere, maybe Joel Salatin, that mob grazing behavior needs a certain minimum number of cattle before the mob mentality kicks in. Does anybody have any experience with this? He's only small scale.
I see it at the other end. I think when it's wet and you have more than 40 cows in a mob, they start milling round a lot more. If you get a night of blashy weather, under 40, they're a lot more settled than what they are over 40. And it just seems, I don't know where it is. I think when you've got under 40, the boss cow's the boss cow, and they all know where they stand. Whereas when you go over 40, then they're not quite so sure about that. So, they're always fighting to decide who gets the more sheltered place, and that just on wet nights. When it's dry, big batches don't matter, but when it's wet, it's noticeable how much more soil damage you get from a too big a batch rather than like a nice medium-sized batch. But small batches, no, seem to be fine. Occasionally have a small batch, and it's never a problem.
Thanks to all of our people on the panel, Lee-Anne, Shaun, and Stu, for you powering through in the loud airport. We really appreciate your effort there. Just wanted to say thank you to Regenerate Outcomes. Our next grounded live event will be on December 10th. We'll be talking about the regenerative transition. So, it's easy to talk about the end, what we want it to look like, but it's the in-between from how do we get from where we are to that end. That's the most important bit. So we're going to be talking about that regenerative transition, how to go from A to B, the successes, setbacks, and stories from UK farmers themselves. And again, that's on December 10th. If you're interested in working with us, Stu and myself and our colleagues here in the UK, our services, our consulting services and mentoring are offered through Regenerate Outcomes. So we want to thank them for sponsoring this podcast. And if you're interested in getting your soil carbon baseline and potentially working with us, feel free to reach out to them. So I want to say thank you to everybody, and I hope everybody has a good evening.